2. Yes, you don't need to know 1, 1. But what we're going to do is we're going to find limits graphically and numerically. Okay, graphically and numerically. Okay, and so the very first page I gave you, I need you to look at the bottom of the page, and there's an exploration there. It's in shape, it's shaded. Okay, and what I want you to do is go ahead and complete that exploration. So I want you to go ahead and fill in those values and come up with what f of x is. So what you can do is actually just write down the values in that table if you want. No. I just want you to fill in the values of f of x. We'll take care of the limit.
You have to figure it out. I will not. It's 31.
Okay, now are you guys manually entering in each one? Yeah. Okay. There's a lot easier way, and that's by using the table feature on your calculator. What I want you to do is I want you to, in Y1, I want you to put in.
How do you get to I1 again? Oh, stack.
I want you to go to Y1, and this is what I want you to put.
You said what you said.
Okay. Y1. Put it in. Now this step right here, you're only going to have to do once. Now, when you hit second window, that's actually table set TDL SET. What I want you to do is I want you to change the bottom two things. Independent should be ask, and dependent, I think you just leave alone because I think that's auto. Okay? So when all is said and done, ask should be highlighted, and then dependent should be, auto should be highlighted. So then now I want you to go to second graph. You're going to notice there's a table. It's going to look real similar to like an Excel spreadsheet. And you're going to have X and you're going to have Y1. So in X, I want you to type in these values.
It solves it instantly.
Exactly. Okay. So the nice thing about that is
You get all right answers. We got an error for 2. Oh, okay, Mr. Smart, 31 on ACQ. Smart.
Okay, so like what were some of your sample values for 1.75? 0.75? It won't. It only, and then you have to overwrite them. Yeah. You get an error, okay? Okay, so you kind of see the pattern here. Now, what is happening here is this graph is approaching a value. If you think about things, if I look at this value, if I look at these, okay, I go from 0.75 to 0.9 to 0.99 to 0.999. As I get closer and closer to 2, as I get closer and closer to 2, what does this number get closer and closer to? To the number 1. Okay. Now, I want you to do the same thing here, except for you've got to shift your thinking. Instead of going this way, we're going to come backwards. So we're going to start right and move left. So I'm going to move this way. So as I move along this way, as I get closer and closer and closer to the number 2 from this direction, what y value does it look like I'm going to hit? 1. This is the underlying concept of a limit. Okay? A limit is what a graph approaches as it gets closer and closer and closer to a specified value. Okay? So, in other words, what does a limit do? It describes a graph's behavior at a specific point. Okay? I'm going to say that again because it's pretty important. A limit describes a graph's behavior at a specific point. Okay. And so what ends up happening is you're going to recognize this right here. This is the symbol for a limit. Or not the symbol, this is how we write a limit. And this was actually written down for you in pre-calc in section 2, or it might have been section 3. But we wrote that down, because I actually should have taught it the other day. Okay, but remember what this means. This is the limit of f of x. As x approaches c. And is L, or equals L. Now the thing about a limit, okay, this needs to be a number. In order for a limit to exist, that needs to be a number. So let's think back to that problem we just got done doing. Okay. The limit as x approaches 2, x squared minus 3x plus 2 over x minus 2. What do you think that's going to equal? So based on what we just got done doing and what we looked at the previous slide, what do you think this limit equals? 1. The reason why it equals 1. Okay, let's go back to that previous slide. The reason why it equals 1 is because from the left it approaches 1, and from the right it approaches 1. If these two things do not match, you can't get an answer. Those two, yes, those two have to match. Now this is the thing. Notice here we got an error. This is actually right here, it was undefined. But remember the definition of limit, it just describes a graph's behavior. It doesn't say specifically this is what it is at 2. It says around 2, it's going to be 1. So, okay, so let's go ahead and look at another one. All right, what I want you to do is I want you to go ahead and graph the following. Okay, I want you to graph f of x equals, okay, let's just go with, I don't know. How do you clear y1?
Around that x column.
What x?
Table set. Oh.
So x over square root of x plus 1 minus 1. Now how are you going to enter this in on the calculator? X divided by parentheses, root x plus 1 minus 1 end parentheses. Okay. Window, you can go to z decimal if you want. And so my question is, what does that equal? What does that equal? So this is what's going to happen. You're getting a graph right now, and it looks something like okay. So we want to know, what does the limit equal at 0? So this is what you're going to do. Remember on the table, what we did is we looked at values to the left and values to the right. So I'm going to do the same thing. I'm going to start with values to the left, so I'm going to start here. And as I move along this graph, kind of like I'm doing the table, what y value does it look like I'm getting closer to? 2. If I come here on the right and I move along the graph and I'm going towards 0, what y value does it look like I'm going closer to? 2. 2, so the limit is? 2. There you go.
The answer is 2.
Answer is 2, yes. You need to look at from the left and the right.
It's a lot easier than you
All right, let's look at this one.
Last time though, it went to that x column, and this time it's graphed.
Because I had you graph it. You're going to find limits both graphically, which is what we just did, and by use of a table. So there are 2 ways. And then eventually, you're going to do limits based on algebraic methods.
What did you type in different though? That got us to that one.
You hit second table.
Oh, table set.
Okay. All right, let's look at another one. Okay, f of x equals. This is going to be a piecewise function, guys. So 1 if x doesn't equal 2. And it's going to equal 0 if x equals 2. So you're probably like, what on earth does that mean? Okay. Okay, so what it tells you is that when x is everything but 2, it equals 1. So at x equals 0, what do you get? 1. At x equals 1, what do you get? 1. At x equals 1.5, what do you get? 1. So you get everything up until 2. At 3, you also get 1. So basically, how I write this is, I'm going to go to the number 2, and I'm going to put an open circle, and it's going to equal 1 everywhere else but there. What happens at 2? What does it equal? What does this tell me? 0. So where would 0 be? On the line. So now what ends up happening if I wanted to know the limit in this problem as x approaches 2? So remember again, what do I look at? The left and the right. So if I travel along the graph here from the left, what y value does it look like I'm going to approach? What? Y value? 1. Okay. Because that's what I'm on right now. And as I get closer and closer and closer, I'm still at the number 1. Same thing here. If I'm coming from the right, what y value am I approaching or staying on? 1. What's the limit going to be in that problem? 1. You do not just look at the dot, because some people say it's 0. That's wrong. Okay? You have to look from the left and the right. You aren't seeing this hole coming out. Okay. So,
Can you type in piecewise functions in there?
Not unless we have a specific program in the All right, so let's look at this one. Okay. Graphing 1. The limit as x approaches 0, the absolute value of x divided by x. So we're going to go to y equals. Where can I find the absolute value?
This.
Nope. Well, math, num, abs. Math, num, abs. Okay? So that's where you find absolute value. It's under the math, num, abs.
It's a straight line. Oh, and then it goes up.
It won't graph.
Did I change it out now?
Oh my God. So what ends up happening to your graph? What does it do?
Splits at 0.
Splits at 0. So basically, what ends up happening is the left part of the graph is like this, and then it gets to 0. The right part of the graph is this. And how do I know it's an open circle at 0? What happens if I plug 0 into this function? You get undefined, so it can't happen.
Therefore, you go
So let's think. Let's see. What's the limit from the left? So as I get closer to 0, what'd you say? Negative 1. What's the limit from the right? Positive 1. What's the limit going to be? What did you remember I said about the two sides? They have to be the same. And if they are not the same, that means there's not a limit in this one. And so how we answer there's not a limit is we put D and E. And what that means is that means does not exist. Okay, so the limit does not exist. D and E. Okay, next one I want you to graph. 1 divided by x squared. Okay? 1 divided by x squared. And we're looking at the limit as x approaches 0. So what's the graph do? Goes up, and it goes up. Yeah, well, down. I see what you're saying. Yeah, down. So what value does it approach from the left? You said it earlier, infinity, okay? Because it keeps going on forever and ever. Keeps going up and up and up. What about from the right? Positive infinity. Okay? What's your answer going to be? Technically, no. Because what did I tell you that number? It's not a number. Okay? So technically, this one is another D and E. Eventually, we will get to these, and I'm going to have you answer infinity and non-infinity, but the big thing you need to understand is that technically does not exist because it does not approach a specific number. For right now, I want you to put D and E on these. What's the point of limits? Limits, there's a lot of things limits can be used for. Talk about it tomorrow. We're about done.
This is not an application class.
This isn't?
I need you to turn to page 51. That's your next one in your handout. Okay. We're going to look at oscillating behavior. So the best way for you to have oscillating behavior is for you to look at that sheet I gave you. That example, figure 1.10 on the left, that is called oscillating behavior because that graph oscillates between two specific values. If you have a graph and get something that is oscillating, the graph does not exist because you can't pinpoint which of the two it's going to hit. So that would be a DNE. Now, how it's going to look when you graph that is it's going to look like figure 1.11 down below. So it will look like that figure below. Whenever you have something like that, it's going to be DNE. So the other thing I want you to look at is that table. It says common types of behavior associated with non-existence of a limit. Okay, those are 3 things in that table. The first thing, it says f of x approaches a different number from the right side of c than it approaches from the left side. So the limit from the left doesn't equal limit from right. We already did that. F of x increases or decreases without bound. So in other words, that's infinity or negative infinity. And then last but not least is oscillating. So you will get does not exist whenever the limit from the left doesn't equal limit from the right, if it goes to positive or negative infinity, and if it oscillates. So that's the DNE ones. Okay? Questions?
Okay, I got that. I grabbed it.
Okay, so this is what I need you to do. Okay? I need you to do for me, I'm going to have you do 5 of the problems on, I'm going to have you do, let's do with 1, 2,
3.
Who's good guess, Ross?
1, 2,
Holy
3,
cannoli.
1, 2, 3, 6, 7, and then 9 through 18. Okay, from this section. Nope.